Welcome to Speech Emotion Recognition. This is a third in a series of research projects for me on emotion recognition. The first one was in text, the second one in video, and now in speech. And I chose this time to use graphic neural networks because I've never really used a graphic neural network for anything serious, and I thought it sounded cool. And I looked it up, and apparently people thought you could use that for audio signals, so here we are. And as it turned out, partly maybe some luck, this turned out to be, well, this will be published shortly, and as the first GNN doing emotion recognition on the CREMA-D dataset. It's also the first model of any kind, or at least lightweight models, that does rater disagreement. When the annotators, you don't average the annotators, you actually use their differences as signal. And the first to use all 6 emotions, all the data, and speaker independent split, all the data meaning annotations. Why does this matter? My interest is in applying these things to psychology, to mental health specifically, and recognizing emotions is very important to psychologists. This particular model is a 2-level hierarchical heterogeneous graphic neural network. One part of it is doing temporal, going frame by frame with all of the audio data, and the second part is the emotion raters and with all their disagreements on videos, on emotions. There is, as I mentioned, a speaker independent split, so we don't have data corruption, data leakage, which I found in a number of the papers that was in the literature review that accompanies this report. The class distribution takes advantage of it because there is quite a difference between the different classes. There is an imbalance problem, and handling that through a number of different ways. And yeah, as you see here, you can see quite a bit of difference between the different classes. Now, just going by chance, you would get about 1 out of 6 chance because there's 6 different classes of emotions. And I averaged about 1 out of 3, and actual humans on the data set could not do better than 40%. And I use the macro F1 statistic because it more fairly represents unbalanced data sets.